Hi, this is Mrs. Barbara. This is Physics Chapter 11, Wave Behavior, Video 6. Today's topic is resonance and polarization. The objectives are: know the definition of resonance and polarization of light waves, understand how resonance is produced and what its effects are on other objects with the same natural frequency, understand only transverse waves can be polarized, be able to explain the relationship between resonance and natural frequency, be able to select situations in which polarization is occurring or may occur, be able to determine the effects of using more than one polarizer on a wave. Natural frequency. Nearly all objects, when hit, struck, or plugged, or strummed, or somehow disturbed, will vibrate. The frequency or frequencies at which object tends to vibrate with when disturbed is known as natural frequency of the object. Here are three. Coins has chimes has its sound, and so its bell has its sound. Next one is force vibration. Force vibration is a type of vibration at which a force is repeatedly applied to a mechanical system. The body vibrates as long as external force is present. This vibration tries to follow the character of externally applied force in the terminal frequency. So whatever you push, that's how the swing is going to vibrate. Resonance. Resonance happens when applied periodic force whose frequency matches the system's natural frequency. The applied force will result in increasing amplitude of the system. That's a resonance. So for example, when you push the swing with its natural frequency kind of in sync, you'll result a bigger amplitude. Here's another example for singing rod.
Singing rod. John will create large amplitude waves at the natural frequency of this aluminum rod. He puts sticky rosin on his fingers so he can grip the rod tightly. As he pulls the rod, it sings at its natural frequency. Manoj uses the foam cup as a speaker to show that the vibrations are longitudinal, along the length of the rod.
Okay. So one frequency of the okay. So singing rod is resonance. Okay, next one is sympathetic resonance or sympathetic vibration. Sympathetic resonance or sympathetic vibration is harmonic phenomena wherein a formerly passive string or vibratory body responds to external vibrations to which it has a harmonic likeness, such as this. So here's two pendulums. One is vibrating will cause the other to vibrate at the same frequency. That's because they have both pendulums have the same natural frequency. And here is another video to show you how a voice can break a glass. This only happens when the voice matches the frequency of the glass, and the glass that will result a glass to vibrate and break. The vibrating straw shows the glass is vibrating, and finally it broke.
Yes. All right.
Okay. Sympathetic resonance is resonance. So sympathetic resonance is resonance. That is because even though there is no direct applied force on the second object, the particles in the second object are forced into vibration through air or other particle connections, when the first object vibrating at the same natural frequency of the second object. And this is actually how, we have a sound box such as violin O viola. This is because the bridge connector string is making the box vibrate. So more particles start to vibrate, produce a louder sound. So condition for sympathetic resonance are two conditions. First, the frequency of the periodic force has to be equal to the natural frequency of the object it applies to. So the two objects must have the same natural frequency. Second, the amplitude of original wave has to be big enough. For example, the sound breaking the glass, if the sound is just a whisper, the glass is not going to break. Here is another demonstration to show sympathetic resonance. Here, two tuning forks are connected to the sound box. This box is actually called a sound box because it's making the sound louder. You probably heard the second tuning fork already had a sound. So the first tuning fork make the second tuning fork vibrate. Now they have different frequencies, and let's see if resonance will vibrate. Nothing happened because the two objects has different frequency. But we can observe the interference of two sound waves, as a matter of fact. That's interference of two sound waves result in beats. Why is sky blue? The color of the sky is related to resonance. The two most common types of matter present in the atmosphere are gaseous nitrogen and oxygen. So these particles are most effective in scattering the higher frequency portion of the visible light spectrum, such as blue light and violet light. This scattering process involves the absorption of light wave by an atom, followed by re-emission of the light wave in a variety of directions. So all high-frequency light are scattered. However, our eyes are more sensitive to the light with blue frequencies. Thus, we view the sky as being blue in color. So here's light with all different colors, only the blue and violet are scattered. All the other colors pass right through because they do not have the natural frequency as the hydrogen and the oxygen, as nitrogen and oxygen. Now, what makes the sunset red? So as the sun gets lower in the sky, its light is passing through more of the atmosphere to reach us. So here's the sun in the midday, here's the sunset in the evening. So the distance is much longer. So that means even more blue light are scattered, allowing the reds and yellows to pass straight through to our eyes. That's why everything seems to be the cloud reflect the red light and orange light, the lower frequencies of light. Next topic is polarization. So we talk about light is transverse wave. Actually, light vibrates in different planes. So this is originally light right over here. So light wave, which is vibrating in more than one plane, is referred to as unpolarized light. So when unpolarized light passes through a polarizer, such as this gray disk, it is reflected from a surface and it becomes polarized, which means the light vibrates in one plane. So polarized light means it vibrates in one plane. In this case, it's vibrating in the horizontal plane. In this case, it's vibrating in the vertical plane. So to polarize the light, we need a polarizer. The most common method of polarization involves using a Polaroid filter. Polaroid filter are made of a special material which is capable of blocking one of the two planes of vibration of an electromagnetic wave, such as light. So when unpolarized light is transmitted through Polaroid filter, it emerges just with 1/2 of its intensity. So here you can basically categorize all the planes into two, vertical or horizontal. When you pass through this filter, only 1/2 of it passes. The other half is blocked. But suppose you pass through two filters that they are perpendicular to each other. First, a vertical pass, then you use a horizontal one, then no light will pass through the second one. So take a look, here is a filter. It's actually two filters. So the first one, they both line up. The second time, they are perpendicular to each other. So in this case, you don't see anything when they are perpendicular to each other. Here, when they line up, perpendicular, line up, then they are perpendicular to each other. Okay, note the longitudinal wave, such as sound wave, cannot be polarized. Sound wave is longitudinal wave. Sound wave cannot be polarized, only transverse wave can be polarized. Applications of polarization. So a lot of times when light hit a surface, this surface is acting as a polarizer. Reflected light is polarized. So that's why we have sunglasses, because sunglasses from light reflect from surface such as a flat road or smooth water is generally horizontally polarized. And this creates annoying and sometimes dangerous intensity of light that we experience as glare. So polarized lenses contain a special filter that blocks this type of intense reflect light to reduce glare. So we have polarized glasses like this to block the horizontal light. So here is the image with no filter, with filter, no filter, and with filter. As you can see the difference, no filter, and here's filter to prevent glare. Okay. Polarization and 3D film. So we probably all have seen 3D film. How does that work? So three-dimensional movies are actually two movies being shown at the same time. So you have two projectors on the same screen. There are two images. And one of your eyes see one image, the other eye see another image. Your brain actually fuses the two images together, allowing you to see 3 dimensions. That's the gist of it. That's it for today. Thanks for watching.